So I want to put this data into the calculator, and that means I'm going to turn it on. I'm going to hit the stat button to put, well, some statistics stuff in, and hit edit to start putting in some numbers. Now your calculator should have 6 lists in it. If you should by accidentally delete a list by going to L1 and hitting delete, oh, well now I only have 5 lists and now L1 is gone. How do you get that back? Well, if there were numbers in that list, they actually would not be gone. You get that back by going to second, quit, to get back to your home screen, hit stat, do select 5, which is setup editor. Nothing has happened yet. You've just selected that command out of your calculator and hit enter. Done. Now when I go to stat edit, that list 1 that I deleted accidentally a second ago is back. Okay, so let's put our numbers into the calculator, 1 through 9. So 1, enter. 2, enter. 3, 4, 5, 6, 7, 8, 9. Okay. We're not going to be using those numbers a lot during this little presentation, but we will in a little near the end. What we're interested in is this data value. Again, some 2-digit values. You can think of them as test scores if you want, or just any random data. So we have 87, 16, 16, 71, 96, 72, 83, 65, 99, and 78. Something happened. I should have the same number of data in each column. Well, if I scroll back up here, it wasn't by accident. I put 16 in there twice. I really didn't mean to do that. So if I want to take a number out of a list I've accidentally typed in twice, I hit delete. And, oh, crud. Okay, I didn't want to delete both of those 16s. I'm later going to use these counting values as we're going to say that this is the sequence of the tests, and I want to make a time plot. So I want to put that 16 back where it belonged, not at the end, which sometimes is okay. Whoops, I went too far. Which sometimes is okay, but I want to put that 16 back where it belongs. So if you miss a number when you put data into your calculator, I want a 16 to show up again between 87 and 71. So I'm going to put my cursor on 71. And above the delete button, which I use to get rid of the 16s, it says insert. So I do second insert. It gives me a 0 back there where I want the 16 to be. All right, so enter, and we're good to go. I want to show you how to make a box plot and a histogram at the moment with your graphing calculator. Okay, so I want to stop putting data into the calculator. So I'm going to do second, quit, and get back to the home screen. Hit clear to just not distract you with anything there. Stat plot. How am I going to make a stat plot, a scatter plot, or a box plot or histogram? Well, that's a type of statistical plot, which will be in yellow or blue, depending on your calculator. So second, stat plot, unless of course you have a TI Inspire, then you're not going to be watching this video. All my plots are off. That's important if you're just learning how to use your graphing calculator. I don't want any mistakes to show up. So I'm going to choose 1. Oh, and if some of them are on, you can hit 4, and that turns all your plots off at once. There's other ways to do that as well, which you'll see. Okay, I want to go to stat plot 1, and I want to turn it on by hitting enter. Down here you can make a scatter plot with the dots attached with lines, and a histogram. I'd like to focus on that right now. So histogram, enter. You notice that just changed. A minute ago it was asking me for both X and Y's, but a histogram, in all the graphs we've talked about, histogram, stem plot, box plot, which we actually haven't talked about box plots yet, those are univariate data graphs, so univariate graphs. So I only need one list of numbers. So that first list, we put the sequence in. We're not going to deal with that right now. So let's make a histogram and see what that looks like. Zoom. Okay, I've got to clear that out. Let's try it again. Zoom. If I scroll down to 9, you're going to see me just hit 9 later, but zoom 9 is setting up your window for a statistical plot, so zoom standard. Oops, I left some junk in my calculator that shouldn't be there. Looks like a parabola, so I'm going to hit y equals, my regular y equals, not second y equals. And yes, indeed, I've got stuff left in there. So I'm going to clear that out and go back to zoom graph. So I've got a flat-looking histogram here. It's not left to right skewed. It's pretty flat across the top, so I'd call that symmetric. If I hit trace, I've got, oops, Well, no wonder it's so flat. I used the wrong list, because remember we put data in list 1 and in list 2. So I wanted to make a histogram with my actual data. So how do you do that? So second stat plot, go back to choice 1. Oh, that's right, I put the actual data I want to use in list 2. Remember the first column was these numbers, list 2 was these numbers. So I got to come down to X list, and above your 1, 2, 3, 4, 5, 6, L1, L2, these are the lists. These are where you put your data values at. And I put my data into list 2. So I'm going to do second list 2 over the X list value, and now zoom 9. Whoop, clear. Zoom 9, that's zoom stat. Now, wow, that's not much, but that shouldn't be after only putting in 9 numbers. But it's not a very good picture. I'd only have, well, I do have the minimum of 5 class intervals, 1, 2, 3, 4, 5, but not a great picture. Let's hit trace and see what we see. Okay, 16 to 36.75. This is how the calculator is telling you how to read the histogram. That class is for x's greater than or equal to 16 and less than 36.75. Carrying over, we got some decimals in our intervals, but yet our data had no decimals. So what we normally do when we have, when we're making graphing histograms with a graphing calculator is we have to go back and manually change the scale ourselves. And you do that by hitting Window and scrolling down. The X min is a reasonable number. Our minimum value is 16. I'm going to change that to 15. And our X scale is a decimal when none of our data has decimals. That doesn't make much sense. So I'm going to change that to 15 and just sort of let it self-count up to its maximum value. And we won't have a problem with that X max there. It'll refigure that as you go through the histogram. So I'm going to change the X scale to something that's more reasonable, and by changing that from 20 something to 15, I'm going to get more bars, more class intervals, and possibly see a better distribution. Now instead of doing zoom 9, I'm just going to hit graph. And we still kind of see not such a great histogram as far as much shape in that histogram, but again, we only did put 9 numbers in, and I'm doing this more for you just knowing how to use your calculator and not really analyzing a distribution so much. If we hit trace, we can see that now we have nice whole number values for our class intervals, which is nice because our data doesn't have any decimals. And scrolling over, no data between these class intervals, and we have 3 pieces of data between 65 and 75. Again, X is greater than 60 and less than 75. We have 3 pieces of data between 75, X is greater than or equal to 75 and less than 90, and then 2 pieces of data in our last interval. So we've got a histogram with use of our calculator. Awesome. Okay, let's make a box plot. Oh, clearly, you see that outlier out there? There's a small body of data, and then clearly that outlier of 16 is showing up as this bar that's way off by itself. This isn't going to be a good picture since we have such a small set of data, but you can hit Window and change that X scale to an even smaller number and hit Graph. And now we're really seeing that big gap between the 16 and all of the other values, which are starting to now actually show a distribution, I would dare to say very slightly right skewed. Very slightly because there's so few pieces of data. It's not good to, hard to make a shape discussion off of that. Let's make a box plot. So go back to second stat plot and hit 1. So we're going to make a modified box plot and a regular box plot. A regular box plot is going to be, well, let's see what it looks like. Enter on the second icon of the 3rd row. Hit zoom 9 every time you want to make a new stat plot. And we have this graph that looks very, very, very left skewed with this very long whisker. Well, that's not actually left skewed. These 3 intervals, each of which, by the way, kind of getting ahead of myself of where I've talked about in the notes so far, but each one of these intervals hold 25% of your data. So these 3 quarters are all about the same width. Varies a little bit there, but you know, roughly the same width, and then boom, really long whisker. That one really long whisker without this growing interval as you go to the left is actually an indication of an outlier. Let's double check that with something called a modified box plot. So second stat plot, 1. And now I'm going to go down to the, with my right arrow, the modified box plot. That's just got a couple of dots in it. We'll be going over modified box plots in the next video or so, or maybe into section 1.2. And hit enter, zoom 9. And now that modified box plot, what it's done is something called an IQR test for you automatically. That's where you take Q3 minus Q1, find a value, multiply by 1.5, and you add it to Q3, and you subtract it from Q1 to make this interval to help identify outliers. That has not been in my video yet as notes. It will be in your textbook, and I'm sure by now, if you're using these as references, you go through your textbook, you've probably already read about an IQR test, but we'll speak of that tomorrow as well. And there's your outlier, that really long whisker that we had a second ago. Well, now it's nice and short. This is somewhat symmetric. Actually, your intervals are growing a little bit as you go to the right, so maybe that tiny, tiny body of data was a little bit right skewed. But, you know, only 9 numbers again. That's not a good description. You won't get a good shape for that small set of data. But there's your outlier of 16 being highlighted by your calculator doing the IQR test for you. You can't just throw outliers willy-nilly. You have to have a good reason to throw those out. And one way of identifying the cause of outliers is with something called a time plot. Now in your textbook, if you're just starting your textbooks, you haven't actually talked about scatter plots or bivariate data graphs, but you probably have seen a time plot, which is actually a form of a scatter plot. It's a form of a bivariate graph. And whenever you have time, we're going to use the sequence of these scores, if they're test grades, we're going to use these sequence of scores as our variable of time. If you remember, I put these numbers in and said we wouldn't use them for a few minutes. Stat, edit, and here we have list 1 as being the sequence of when these grades were taken or data was collected, and we have the outlier. Clearly we can see the outlier happened early in the data collection process, so it's probably because of use of error, or if it's testing purposes, maybe just not knowing what to expect on tests, or if it's an experiment, maybe user error or miscalibration of tools or something like that. But we're going to identify this outlier with a time plot using our calculator since, again, you know, they only have 9 pieces of data, and I don't want to type a bunch of stuff in while I show you how to use your graphing calculator. So I want to display the L1 and the L2 list at the same time. I want to make a scatter plot where the time is the x-axis and the data now is going to be on the y-axis. So second stat plot, I'm going to go back to stat plot 1. I'm going to turn on the scatter plot option, which is the first one in the first row. And now see what it's doing? It's saying where's the x's and where's the y's. Well, my X list is going to be list 1. That was the sequence of events, and my calculator right now is not set up correctly. So second L1, and for the Y list, it's going to be second L2. So my time is going to be the list 1 or X list, and my data is going to be on the Y list, which was in list 2. Okay, so zoom 9. Let's see what happens. Okay, try that again. Zoom 9. Let's see what happens. There's my time plot. If I hit trace, I can trace along and it'll show me the coordinates of each one of the points. And again, the x coordinate was a sequence of when the data was collected. And our outlier is showing up very early in the data collection process. Again, that could be no good reason to get rid of that piece of data, but if it was learning how to use a new piece of machinery, maybe it was miscalibration or user error, and maybe we have a reason to throw out that outlier through the process of making this time plot. Okay, and I think I might have just a minute left. If I do stat edit, let's do something neat. Let's display this data in both a histogram and a box plot at the same time to see the comparison between the two. So second stat plot, 1. I'm going to have 1 be a histogram, and remember my data was in list 2, not list 1. Okay, now I'm going to arrow up to plot 2 and hit enter. I'm going to turn it on, and below it, below the histogram I made just a second ago or asked for, I'm going to put a box plot underneath the histogram. and zoom 9. And there you go. We have a